Welcome to Cupertino Aviation. In this video, we'll look at some basic but important aerodynamic terms and definitions. Before we can study and understand airplanes and aerodynamics, we need to understand some basic terms. In this video, we won't dig into why these terms are important or the details behind how these ideas work. We'll do that in other videos. For now, we just need to understand what the terms mean. So let's get started with a very general term, airfoil. An airfoil is anything that provides an aerodynamic force when air moves over it. The most common airfoil in aviation, of course, is a wing. The propeller is also an airfoil. It provides thrust to propel the airplane forward when it moves through the air. Wings and propellers are usually what you think of when you hear the word airfoil, but technically, anything that reacts aerodynamically with air is an airfoil. Even the blades on a wind turbine are airfoils. They interact with the wind to spin the generator. So let's look more at the parts of an airfoil. The leading edge is the part of any airfoil that meets the airflow first. Remember that an airfoil is any surface that provides lift when air passes over it. But you'll usually think of the leading edge as the front of the wing or the front edge of the propeller. As you can probably guess, the trailing edge is the back of the wing or the back edge of the propeller. The FAA makes this definition a little more complicated than it needs to be. They talk in terms of the trailing edge being where the airflow above and below the airfoil rejoins. Just remember that the leading edge is the front of an airfoil and the trailing edge is the back. So far, we've seen some terms that are pretty intuitive. Now, we move on to some terms that you'll simply have to memorize and learn. The first one is camber. Camber describes the curve of an airfoil. Most, but not all, airfoils have more curvature on the top than the bottom. So since that curvature is different, we talk about the upper camber and the lower camber of the airfoil. The chord line is an imaginary straight line connecting the leading edge and the trailing edge of an airfoil. We'll see why knowing this is important soon. But first, let's put it all together and see all the terms involving airfoils in one diagram. We keep using the term airfoil, but it's simplest to think in terms of a wing. Other airfoils, like propellers, are very similar. Keep in mind that when we talk about a wing, the same concepts can usually apply to any airfoil. The leading edge is the front edge of the wing. The trailing edge is the back edge of the wing. Camber describes the curvature of the wing, and the chord line is an imaginary line that connects the leading edge to the trailing edge. Now here is where the idea of the chord line becomes important as we look at other features of an airplane wing. The angle of incidence is the angle between the chord line of the wing and the longitudinal axis of the plane. We haven't defined the longitudinal axis yet. We'll get into that detail in another video. For now, just understand that the longitudinal axis is an imaginary line from the nose to the tail. We can drop that longitudinal axis line down, keeping it parallel, to where it meets the trailing edge of the wing. Now we can see the angle between that line and the chord line. This is what we call the angle of incidence. The angle of incidence tells us the angle at which the wing is mounted on the plane. This will be a little different for every model of airplane, depending on what the designers choose to do. We've talked about how an airfoil interacts with air to create an aerodynamic force, otherwise known as lift. Relative wind is the air that moves over the wings to create lift. Don't confuse the term relative wind with what you normally think of when you hear the word wind. When an airplane is moving through the air, even if there isn't any regular wind, there is relative wind moving toward the airplane. It doesn't matter where the nose of the airplane is pointed or where the ground is. Relative wind is always parallel to and opposite to the direction of flight. So remember that relative wind is the air moving toward the aircraft parallel to the direction of flight. Now that we understand relative wind, we can talk about angle of attack. Angle of attack is different than angle of incidence, and the distinction is very important. The angle of incidence is always the same for a particular airplane, since it is the angle between the chord line of the wing and the longitudinal axis of the plane. The way the wing is mounted to the airplane defines the angle of incidence. The angle of attack changes throughout different phases of flight. The angle of attack is the angle between the chord line of the wing and the direction of the relative wind. Since relative wind is always parallel to the direction of flight, we can simply think about angle of attack as the angle between the chord line of the wing and the direction the airplane is traveling. When you think about what an airplane does as it flies, you can see that when a pilot raises the nose of the airplane to climb, the angle of attack increases. When a pilot lowers the nose of the airplane to descend, the angle of attack decreases. What does the angle of incidence do? Nothing. It always stays the same. Attitude is the position of the airplane relative to the horizon. In a less precise sense, it can be thought of as the position of the airplane compared to the ground. We usually talk about attitude in terms of the pitch angle and the bank angle. Pitch angle is the number of degrees nose up or nose down compared to the horizon. Pitch changes for small aircraft are normally fairly gentle, with only up to around 10 degrees of movement up and down. Bank angle is the number of degrees the airplane is tilted left or right. Bank angle during normal flight can be as much as 30 or even 45 degrees. Of course, in aerobatic flight, both pitch and bank, in other words, the attitude of the airplane, can be extreme. The center of gravity of an airplane is something that is calculated before every flight. It is where the entire weight of the airplane is assumed to be concentrated, or in other words, the point at which an airplane would balance if it were possible to suspend it at that point. From a practical perspective, the location of the center of gravity depends on the distribution of weight in the airplane. There are a couple different ways to express the center of gravity of an airplane, and we'll cover those in videos on calculating weight and balance. Just like the center of gravity is a single point that in essence averages the overall weight of an airplane into that single point, the center of pressure is the point along the chord line of the wing where lift and drag are assumed to be located. The reality is that the entire surface of the wing is generating lift and drag, but we can simplify that to a point called center of pressure. We'll see in other videos that for most wings, the center of pressure moves back and forth between the leading edge and the trailing edge of the wing as the angle of attack increases. If you look at almost any airplane, you'll see that the wings do not come straight out from the airplane. Instead, they're angled slightly upward. This angle is called dihedral. We'll look in more detail at the importance of dihedral in other videos. But for now, just know that dihedral is the angle that the wings are slanted upward, and it helps with aircraft stability. When non-pilots hear the word stall, they usually think of the engine stopping. In aviation, the word stall has absolutely nothing to do with the engine. For pilots, stalls are all about the wing. If an airplane's angle of attack exceeds a certain amount, known as the critical angle of attack, usually about 16 to 18 degrees for most small aircraft, the air flowing over the top of the wing breaks away from the wing. This causes the wing to almost completely stop producing lift. But don't worry, as long as you aren't too close to the ground, you can easily recover from a stall. Just lower the nose below the critical angle of attack, air will start flowing over the top of the wing again, and the wing will start producing lift. Sweepback is simply the angle that the wings are slanted rearward. Sweepback is a term worth knowing, but it's not something a private pilot usually concerns himself with much. Slower planes have very little, if any, sweepback. In general, the faster the plane, the more sweepback the wings will have. Remember that the angle of incidence is the angle between the chord line of the wing and the longitudinal axis of the plane. Most airplane wings will have an angle of incidence that varies slightly along the wing root to the wing tip. In other words, the wing is designed so that it is slightly twisted. The angle of incidence is greater at the wing root and becomes progressively smaller as you move toward the wing tip. This helps with stability during a stall. The wing will stall closer to the airplane first, which helps give the pilot warning of an impending stall before the wingtips stall. Like most of the terms we're covering in this video, we'll get into more detail in other videos. For now, just remember that washout describes the fact that the wing is twisted very slightly, so that the angle of incidence is less at the wingtip than at the wing root. The wing planform is simply the shape of the wing when you look at it from above. Most small aircraft have wing planforms that are pretty much rectangular in shape, but you'll see quite a variety of planforms among different aircraft. Now for a couple simple, almost self-explanatory terms that we need to know. The wing area is simply the total surface area of the wing, which we usually express in square feet. When we calculate the wing area, we include the area of the control surfaces. As you can probably guess, the wingspan is the distance from wingtip to wingtip. We've spent most of our time on terms that have to do with the wing. We're in the home stretch now, or maybe you want to think of it as being on final approach. We'll finish up with 4 terms that are important when we start to look in other videos at how forces act on an airplane. If you're lucky enough to remember high school physics, you'll remember vectors. A vector is a concept that visualizes a force and its direction. When you see force vectors drawn, usually the longer the vector, the greater the force. So we see here a small force to the left. Here's a larger force down and to the right. And here's a medium force up and to the right. You get the idea. Speed is simple. It's the distance traveled in a certain amount of time. In your car, you probably think of speed in terms of miles per hour. In most airplanes, it will be expressed in knots, which means nautical miles per hour. 1 knot is 1.15 miles per hour. Don't confuse speed with velocity. Speed is distance traveled in a certain amount of time. Velocity is distance traveled in a certain amount of time and in a certain direction. In other words, velocity has 2 components, speed and direction, so velocity is speed in a direction. If an airplane is flying north at 65 knots, its speed is 65 knots. Its velocity is 65 knots northbound. If these airplanes are all flying at 80 knots, each plane has a speed of 80 knots, but each plane has a different velocity. And finally, acceleration. You probably instinctively think of acceleration as speeding up, since that's how we use the term with cars, and that's true. More generally, acceleration is a change in velocity, whether that's speeding up, slowing down, or changing direction. Remember that velocity is speed in a certain direction. So if acceleration is a change in velocity, just changing direction is considered acceleration. An airplane that is going steady 70 knots while it turns has accelerated, even though the speed didn't change. Memorizing terms isn't the most fun part of flying, but like any field, aviation has its own unique terms. And there are a lot more terms and definitions that you'll need to know as a pilot that we'll cover in other videos. But the terms we just covered are enough to let you get started on your journey into aviation.